Our world is just this wild dance of interconnected systems, right? Everything from economies to ecosystems, our brains to the entire internet. But actually seeing the hidden forces that connect them all, that's the hard part. The feedback loops, the sudden tipping points, visualizing all that is incredibly difficult. So let's dive in. How do we even start to map out all this complexity? I mean, just think about it for a second. How would you actually draw a feedback loop? Let's say on a whiteboard. Something simple, like a thermostat controlling a heater. Sure, you can use some arrows and boxes, but it gets messy really fast, and it's not very precise, is it? Okay, and what about something way bigger? Something way more critical? How do you possibly represent the exact moment a whole system, like say our climate, just flips into a totally new state? Our usual diagrams, they just don't have the words, the vocabulary for these kinds of massive changes. Well, the core idea we're exploring today is this. To really get a handle on reality, to model it properly, we need a whole new language. We need a universal grammar that's built to describe all those relationships, the flows, the transformations that actually define our world. And that language, well, it's called Synergex. All right, so how does Synergex actually plan to solve this? First up, let's look at the fundamental problem it was designed to fix, how to accurately map the complex, dynamic systems that are all around us. Okay, so Synergex's big idea is to treat modeling systems, well, like a language. And just like any language, it's built on a foundation of core components. Think of them like its alphabet and its grammar rules.
And it really comes down to just three fundamental building blocks. Super simple. First, you've got the system. That's basically any entity or process we want to model. You can think of it like a noun. Second, there's the interaction, which describes the flow and the relationship between those systems. Those are our verbs. And third, and this is a big one, you have the semantic kernel. This represents universal patterns that you see over and over again in all different fields.
Now, what's so cool about this, when you look at the table, is just how simple it is. A system is just whatever we decide to put inside these double brackets. An interaction is shown with an arrow, right? It's showing flow or connection. And the semantic kernel, and you got to remember this one, is a universal function marked with this little diamond symbol. That's it. This is the basic grammar we're going to use to build everything else. So, with those building blocks in place, we can start moving from just simple elements to really meaningful expressions. We can start constructing sentences that actually describe how the world works. Let's see how we can start building with them. Right away, we can start describing different kinds of relationships. See that single arrow? That shows a one-way, directed flow. A great example is the sun providing energy for photosynthesis. It only goes one way. But a double-sided arrow, that shows a mutual, reciprocal interaction, like the classic relationship between a predator and its prey. The syntax itself is telling the story. And check this out. This really shows you how nuanced the language is. It doesn't just model things that are working, it can also model failure. This expression right here clearly shows a signal being sent, but it gets blocked before it can trigger a response. Just think about how useful that could be for, say, debugging a really complex system. Okay, so simple interactions are one thing. That's cool. But the real power of Synergex comes from its ability to model the much deeper, more complex dynamics, the stuff that's often totally invisible to us. And this is where those semantic kernels come in. These things are like the secret weapons of the language. They're these universal motifs or patterns that just pop up everywhere in all sorts of different systems. A regulator pattern, for example, isn't just in biology. You'll find the exact same pattern in economics. An amplifier exists in social media and in our own immune systems. These kernels give us this incredibly powerful shorthand for describing complex functions that would otherwise take pages and pages to explain. And hey, remember that feedback loop we couldn't draw at the beginning? Well, look at this. By using the feedback loop operator, that's that little circle symbol, the entire dynamic of a thermostat regulating a room is captured in one single, clean, totally unambiguous expression. It's just elegant and unbelievably clear. And this is the real kicker. We can now finally answer our first questions. The language has a specific symbol for a phase shift, or a tipping point, that little lightning bolt arrow. This expression right here precisely models a climate system going through a sudden, dramatic change into a completely new state. We've gone from some vague drawing to a precise, powerful statement. But Synergex isn't just some technical tool for scientists, and this is where it gets really fascinating. The people who created it see it as a whole new framework for thought, one that can model abstract concepts we usually save for philosophy class, like ethics, value, even purpose. Take the ethical balance operator, for example. It lets us formally represent these incredibly complex societal trade-offs. Now, this expression doesn't give us the right answer, of course, but what it does do is perfectly frame that fundamental tension between the system of privacy on one hand and security on the other. It lets us have a much more structured conversation about these really difficult choices. It even brings in philosophical concepts. The infinite game operator can be used to describe systems where the goal isn't to win, but simply to keep the game going forever. And when you think about it, isn't that the goal of a civilization, or of science, or a healthy community? It's a really profound shift in how we even define what success means. And maybe most profoundly of all, it can model the very act of creation itself. What we're seeing here is an internal mental model, a vision inside someone's head being turned into a real-world system, a startup company. It's literally a language for turning ideas into reality. So that's a quick tour of the grammar of Synergex. It really offers a new lens to see the world, not as just a collection of static things, but as this dynamic web of interactions and patterns. And it leaves us with a really fascinating question. If you had this language, if you could think this way, what hidden connections in your world could you finally see and bring to light?